So here is another question on simple harmonic motion. So it is given that a block of mass 1 kg, it is fastened to a spring with a spring constant 50 Newton per meter. The block is pulled to a distance of x is equal to 10 centimeters from its equilibrium position or mean position at x is equal to 0 centimeter, the origin, the reference, and the whole arrangement is placed on a frictionless surface, okay, and happens from rest at t equals to 0 seconds. We have to write the expression for the displacement, instantaneous displacement as a function of time, and velocity as a function of time, xt and vt. So let us try to understand the arrangement. So first we have a frictionless surface, okay, frictionless surface. Then we have a spring, okay, we have a spring. Which is connected to a mass, okay. So this mass, it is stretched to x is equal to 10 centimeter, okay, x is equal to 10 centimeter. So let this be the reference, x is equal to 0, and here it is stretched to x is equal to 10 centimeter, and here this is the spring with spring constant, how much? 50 Newton per meter. So here it is given this much. So from here we can figure out that for this SHM motion the amplitude A is equal to 10 centimeter or 0.1 meter. That is the amplitude. From here it will go this way and that way, like that. Now here the spring constant K and angular frequency, they are related as omega is equal to root over of K by m, spring constant by mass. Okay, we have studied it in the spring motion when we are discussing simple harmonic motion. So here the angular frequency will be equal to root over of 50 Newton per meter by 1 kg. Yes, it is a 1 kg mass. Yes, so it is a 1 kg mass. M is equal to 1 kg. So that is equal to root over 50, which is equal to, it is coming around 7.07 radians per second. That is equal to omega. The basic SHM displacement equation is given by xt is equal to a sine omega t. So here substituting the values, a is equal to 0.1 meter, sine omega, which is equal to 7.07 t. Velocity vt is equal to dxt by dt, which is equal to a omega cos omega t. Okay, so this will be equal to a omega, which is 0.1 into 7.07 cos omega t, 7.07 t. So that is equal to 0.707 cos 7.07 t. This is the velocity equation function, okay, vt. and this is the displacement equation xt. So the important thing here to remember is this: angular frequency for spring and mass connected system executing simple harmonic motion, angular frequency is given by root over of k by m, where k is the spring constant and m is the mass. Okay, so this is the thing, and remaining is very simple. Just remember the standard format of the basic format of SHM equation, and all we have to do is just substitute the values. Okay, so here is another question on simple harmonic motion. So it is given that in a HCl molecule with H alone oscillating, if the oscillation of the molecule shows a frequency of 9 into 10 to the power 13 second inverse or hertz, we have to calculate the value of force constant. So it is assuming that it is simple harmonic motion in nature. Okay, the motion of hydrogen H plus Cl minus, H plus is oscillating alone in simple harmonic motion. Okay, and another extra data which is given, which I missed here, is the Avogadro's number. Okay, which is given 6 into 10 to the power 26 per kg mole. Okay, this is the given data and we have to use this only. Okay, so here first the mass of one, the H atom, okay, that we have to take into consideration. So it will be the atomic mass by the Avogadro's number, which will be 1 by 6 into 10 to the power 26. We'll keep it as it is. Okay, this much kgs. Okay, then we know that for SHM, simple harmonic motion, the angular frequency is given by the force constant, okay, divided by the mass, okay, the object or the particle. Here the mass which we are considering is the hydrogen atom, because only H that is oscillating in SHM as per the question. We are not going into the chemistry, deep into the chemistry, we are just going as per the information which is given in the question to get the desired result. So that implies omega square is equal to k by m, or that implies k is equal to omega square m. Okay, here the frequency is given 9 into 10 to the power 13 second inverse. So here it will be, if we substitute omega with 2 pi f, it will be 2 pi f whole square m. So we have everything with us. We have the value of f, we have the value of m. So simply we have to put the values, that is 2 pi into 9 into 10 to the power 13 whole square into m, which is 1 by 6 into 10 to the power 26. Simply we have to put the values and get the result. So it is coming around, okay, the value is coming around 533.4 Newton per meter. Okay, that is the value of the force constant K. Okay, so this is the thing. So here the two important things that are important, crucial to solving this. First is the mass of one H atom, which is calculated as per the information, the Avogadro's number that is given per kg mole, that's why kg, the result we got in kg. Then this formula. Angular frequency in SHM is equal to root over of force constant by mass. These two formulas is they are important to getting the result that we got here.